Hello ladies and gentlemen, I am Dr. Claudia Albers, Planet X researcher and professional physicist. And I'd like to talk to you about a short article I have just written entitled Stellar Cores and Space Weather on September 5th, 2017. And after reviewing some data regarding the latest CME and the latest solar flares coming from the sunspot AR2673, I just couldn't help but write a short article on this. So let's start with the first images. These are SOHO-LASCO C3 images showing the CME that erupted from sunspot AR2673. And as you can see, this is where we start to see the CME from behind the occulter. And in these images, the little white circle shows the size of the sun, and the occulter goes out to 3.5 radii from the center of the sun. So at 2018, we see the CME had already arrived at 3.5 radii from the center of the sun. And the CME here later on, as you can see, seems to be coming almost from every direction from the sun. This is not because it is extremely strong. It is a strong CME, but it was the fact that AR2673 was Earth-facing at the time. So the CME seems to develop almost in every direction. Then this sunspot is acted very strangely because it suddenly grew dramatically and became extremely active as the sun rotated so that it faced the Earth. So what we see here is what happened to the sunspot. This is the sunspot AR2673 on September 2nd at 18 UTC, and here on September 4th at 3 UTC. So early in the morning UTC time, as you can see, it grew dramatically. And then it started having M-class solar flares. And we see in this diagram the M-class solar flares it had on September 4th. There was an M1 and another M1 and then an M5. This happened at 2033, and we can read the time here. The spaces here are 3 hours between the little bars, or 3 hours. We can figure that out because this is a 24-hour time span, and there are 8 of these time periods. 1, 2, 3, 4, 5, 6, 7, 8. 24 divided by 83. So it's a time span of 3 hours each. And this one, as you can see, is right before the second last one. So if that's 24, this would be at 21 or 9 UTC. And this was just before at 2033. And the one before was between 15 and 18 UTC. So this would be an M1, M1, that was an M5, and we can read it here, 1, 2, 3, 4, 5, M5. So this is how we read what kind of solar flare we have. But what is surprising is this does not coincide with the CME we had. Remember, the CME was already visible at 2018 at 3.5 radii, and yet the strongest sun flare occurred at 2033 after that. So the solar flare and the CME do not coincide, and this is strange. It's also strange that the sunspot developed quickly as it turned to face the Earth. And to me, I see that as evidence of the sun being affected externally by an object that was between the Earth and the sun. And these are, of course, brown dwarf stars, or as I like to call them, stellar cores. And the CME seems to have been caused by one of these stellar cores going up to this region and getting very close to that sunspot. And as we know, and as I've written about before, these stellar cores connect magnetically with the sun. They pull on the sun's magnetic field. They then have a particle flux transfer between the sun and themselves. And so they exchange plasma with the sun. The sun gets the low energy plasma, and they absorb plasma from the sun. And as we can see, this is the sun's magnetic field. Lines are pulled outwards. They then close inside the stellar core or the brown dwarf star. And then we have the returning magnetic field lines. So the sun's particles spiral along the outgoing field lines, moving towards the object, and this object's plasma moves towards the sun along the returning field lines. And there is then this magnetic connection between the two. And of course, if there is a sunspot, this is what actually causes coronal holes. But where there is a sunspot, it will also pull on the magnetic field lines, thus making it easier for particles to erupt from the sun, and thus strengthening the effect of CMEs, or making CMEs possible where normally you wouldn't have one. So I believe this is what is happening with the sun. The sun is also being weakened, and as it weakens, it has a lesser ability to hold on to its surface plasma, this would lead to increased solar activity, and leading to geomagnetic storms, which will in turn lead to increased earthquake and volcanic activity on Earth. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.